Okay, so I think we can start. Hello and welcome to this Hyperledger Sweden meetup this Saturday. And today, my name is Roland. I'm your host for today. And in this session and in the upcoming sessions, we're going to build a new consortium with you. And I've called this the Sunshine Company, sunshine.com. And in this session and in the next sessions, we will start a new consortium step by step. And you will find to this consortium all configuration files in a GitHub repo. So in a way that you can follow this example and you can also do a little bit practice and try to make this sample running also on your own machine. And yeah, so at the beginning, I can give you a little bit an overview of the sunshine.com. I call this the birth of a consortium. So we will start very small with this. So we have here a consortium, the Sunshine, and we have one organization. And we have one organization, and we have a order organization as well. So this first organization will have only 2 peers and a CLI container, and we will use one channel, and we will use on this channel the pre-configured chain code, which we have used also in the last sessions from the developer part, and these simple access control chain code. This is a chain code which you can find in the Fabric samples, and it's really basic chain code where you can store a key and the value. So, and for the beginning, we will use the solo orderer consortium algorithms, and with this we can start with a really small example and consortium, and we will do this to come away from the example.com examples which you can find in the Fabric examples. And so we have to so you will see what you have to change when you're going to try when you're going to build your own consortium. And in this first step, we will do it with Cryptogen. And because when we start, it's a little bit easier to start with the Cryptogen tool, because as a replacement for the Fabric CA, because this Fabric CA, we have to copy a lot of certificates, and we need a structure, and Cryptogen gives us the structure in the first way, so that we can study these examples, and then we can, in the later sessions, we can use Fabric CA also to create the crypto materials for the peers, for the orderers, and so on. But that will come to a later time, because it's a very heavy task. So because we have to copy a lot of things. But this session today is that you have a good understanding how you can start, and what is needed to start to build your own consortium. And for this, I will guide you through the elements which we need. So we need the crypto config. This is a config file, and also an folder, which all the structure we need. Then we need this Configtx YAML file. It's also a configuration file. You will see for what is this needed and what we have to edit to create our example. Then we have to look into a Docker Compose file. So all these elements are created with Docker in Docker containers, and to organize these Docker containers, Docker Compose is used here, and you will see how we can create these and what is needed to build this kind of network. And then we have to initialize the network. So we have to create the crypto materials, we have to create the channel, we have to create the Genesis block, and we have to install and instantiate the chain code. And then we can query and invoke our chain code. So, and that's also here in the operation part of the network: create channel, join channel, instantiate, and invoke query. So, and in the end of this example, you will have this system running. So you have a single organization with two peers, and you can switch between these two peers, peer 0 and peer 1, with the CLI container. And you have an orderer system from type solo. And with this, you can play a little bit. So, and in the further sessions, we are going to try to add we are going to try to add a third peer. We can enable TLS in this example. We can also change the orderer system from solo to Raft. So Raft is really good because in the current version of 2.2, solo ordering system and Kafka ordering system are deprecated. So in the end, I think Raft will be the default consensus algorithms for Fabric, and that's a good start that we can see how we can configure Raft for the system. And this week, I have also tried the example where we can add another peer, but another peer on a different host. So that's a pretty exciting example, which I have provided. So, but that's one for our next session. So, what is the creation process for? So, first you need your big picture. So this is, I think, you have to map a picture. What is your system, which organization, which peers you need, and so on. So you should make a picture from this, like I have done it here in the first slide. So, and from this on, we have three parts what we have to do in this blue boxes. So we have to configure this crypto config file. Yeah. This is a file we have to look into. Then we have to configure the Configtx YAML file, and then we have to configure the Docker Compose YAML file. So these three configuration files we need and to edit that we can have an consortium like this we have seen in the picture. So that's the first part we have to do after we have a good idea from what we are going to do. And the second part is that we generate all the crypto materials. So we have to generate the certificates, the private keys, the public keys, and so on. And for this, we will use a crypto. Again, this is the tool for development, for prototyping, and it's a replacement for Fabric CA or any other system where we can generate X509 certificates. So this is the first step, so that we can generate the artifacts. The second step is we have to create a Genesis block for the orderer. So that's another task we have to do. And then we have to create the channel configuration for our channels. And, but not needed now in this example for a single organization, we have to create an update transaction for the anchor peer. So, and, but we have only one organization, so we don't have a second organization, and we don't need this, but that is to be here complete, so that we will have all steps complete here. And this is the second line here. The second line we have to do in the second step. And then we can start the network and operate the network and try to do what we want with this network and install chain code and so on. So these are the steps from a high level which we are going to do to create a new network. And for the beginning, we have to know what the terms are for. So this crypto-config YAML file, this is a definition of organization managing order nodes for the crypto-config folder. So this, we will look later in detail for this, but this file is needed to define the organization. And this file creates a crypto material, and this is stored in this crypto-config folder here. And this crypto-config folder is at the place where all the crypto material is generated when we use the crypto-config tool for us. And it's, I think, a replacement for the Fabric CI tool. So these both elements belongs together. And the third thing is the Configtx YAML file. That contains information related to the configuration of the network structure. So this is also a file we are looking into and have to make some changes, which fits our needs. And the Docker Compose file is the definition for the network structure. And we have seen, we can in this, when we look into the Fabric samples, we have also base Docker Compose files and or sub Docker Compose files, which we can include in a main Docker Compose file. And but we can do this. I have in my example, I have the Docker base file or the peer base file extracted. So that's, but we can do this, but we don't have to do this if we don't want. So, but it's a little bit easier to do this because when we have more peers, then we have to put all the config variables or TLS configuration variables only in a single file, and not we have to copy this all in every peer section. So, but these files are needed, and this folder is also needed. So these are the main configuration elements for a Fabric network. And the first thing, Cryptogen. Cryptogen is a utility tool for the crypto materials for the key management or the key generation. So that's also only for testing and for prototyping. And as I have mentioned, you can see there's a replacement for a certified authority and something like Fabric CA. This is the way we should do it in the Fabric world. And here we have two important commands. And as you can see, Cryptogen generate, this is the main command to generate the crypto material. And Cryptogen extend is also interesting, but not needed for today. But this is for the next time when we extend the network. So when we will have, today we have 2 peers, when we have 3 or 4 peers, then we can use the extend command here, and then we will have the Cryptogen will not override and delete and write new crypto material. So he will extend the existing crypto materials and extend it only with the second peer or the third peer and so on. So, and for this we have here the config parameter. This is our config file, and the input option here or parameter is where the crypto materials lives for. So these both commands are needed. So this we will use today, and this is maybe a command for the next session. But keep in mind, Cryptogen is only for the testing and not for production. So, and Configtx gen is the next command line tool, which we have to look a little bit, and we have to use it. So, and this command line tool works with the Configtx YAML file together. So, and we need this tool today for 3 different commands. So the first thing is for the generation of the Genesis block. So that is the first block in the network. And we can create also the channel configuration transaction and these anchor beer update transactions. So these are the commands here. So this, but all information from this for this command comes from the Configtx YAML file. So that's important. These both elements belongs together. Okay, so I have here two links for you. So the first is, of course, read the docs. So everything what we have seen here is from the 1.4 documentation, and I use 1.48. That's the latest version from Fabric. And here you have the link to the GitHub repo, and there you will find the configuration files for this. So, and now let's have a look in this thing. So the first thing when we start to do this, we have to create this crypto config YAML file. So it's a little bit larger. So the best thing is we make a copy from the Fabric samples. We can copy this file, and then we can make our adjustments to this file. And in this file, as you can see, we have to define some information about our organization, about our network. So this is the orderer organization. That's we have to change here the sunshine.com, and that's the orderer element. The host name is orderer, and this will create orderer.sunshine.com configuration. And the same is for our peer organizations. So we have to set up here our peer organization. So that's organization 1. And we have to configure here our domain, producer.sunshine.com. And we can here in this template, there's a count key, and we say this is set to 2. So that means that we will have 2 peers in this organization. When we want to have 3 or 4, then we can change this number, and then crypto again will create these crypto materials for this. When we extend our network, then we have also changed this value here, so we can make then 3 or 4, and with the cryptogen extend command, the tool will generate the crypto material for 2 more peers here in this. Yeah. And the same is for the users. So by default, every organization will have here one admin user and 1 normal user. So, and when you change here this to 2 or 3, then you will have 2 users, 3 users, and the admin user is always included. So users are also users and not admin. So we have by default 1 admin and 1 user, and when we increase this number, then we will have 2 or 3 users and so on. But for the users, it's not so important. So we can use also with cryptogen Fabric CA, because that's also an advantage when we use cryptogen. So all needed crypto material for the usage of Fabric CA is also generated. So we can create a single Fabric CA container and make some make some adjustment to the Docker Compose file, and then we can create third-tier users through the Fabric CA command. So that's maybe a good part for the next time to extend the network. When we are going to add a new peer or a new or more users, then we can use this way for this. But that's all here now for now. So that's all. And with this, we will have 1 orderer, we will have 1 peer organization with 2 peers, and one user, and the user is called user one, and by default, an admin user is also generated for this. So I think that's very easy to do. And the second step is a little bit complex. It's more complex. So the Configtx YAML file. So these are informations about our network itself, about the membership service provider, and so on. So, but the file is also structured similar to the crypto config file. So we have a section here, orderer, and in this orderer section, we have to define here the membership service provider path. As you can see here, this is the path here, and that is very important to know that the crypto config, when you change the paths, you have to be carefully that you know what is on the proper position, and so because otherwise you will have a lot of errors, and the system cannot find any path. So, but when we be carefully, we can change this, and we can say, okay, this is our sunshine.com organization, orderer organization, and we can have different orderers. Of course, we can have different orderers. When we think about Raft, more than one orderer. Also, in the case of Kafka, we need more than one orderer to have a crash fault tolerant system. And these orderer membership service provider files are under this path. So, and here under orderers, you will have orderer 01, orderer 02, and so on. So, and that's the path for this. But that's everything the same. You have only to change the names here when you come away from the example.com. And the name and the ID, we have to be aware. So for the order organization, I haven't changed this. So these are the policies, the default policies for this. And as we can leave this now for the moment. So these are default settings, and we don't have to change it anymore. And for our producer organization, that's the only organization we have in this. This is original named organization 1, and we call it producer. And then we have to adjust to the name producer MSP and the ID also of producer MSP. So, and then here's the same thing. We have to change here in the crypto config. There's the folder to producer sunshine.com, and in this peer organization folder, we will have, when we have 2 or more organizations, we will have here the base structure for organization 2, 3, and so on. So that's the same like here. So you have the orderers, and then you will have different orderers. And here you have peer organizations, and then you will have different peer organizations, how many you want. And there's wieder the path to this membership service provider. And here I have changed this org1 MSP and ID org1 MSP to a more understandable name for me. I call this producer MSP because of our business requirements from the picture. And then we have to adjust this path as well. So we have also to change this ID. So the producer MSP ID is for the, but it's not necessary to know for the moment what is the policies are for. So that's a part we should look in a separate way. The only thing to know here is when you change the name and the producer here, you have also to change this one because this belongs to the ID here. And here is the anchor peer. So anchor peer is the peer 0, and yeah. So, but we don't need in fact the anchor peer for this example because the anchor peer is responsible for the connection between 2 organizations. And in the case of the gossip protocol looks for what is the anchor peer for organization 2, organization 3, and this is the link, the bridge to the other organizations. And this has happened over the interface. But this is also a different point, how gossip works and how this works with anchor blocks. So. And yeah, capabilities. So these are also default settings. We have to look so much into this now, so we can leave this. These are also default, and also this application defaults. Yeah. So more interesting is here the part. So as we have seen, as we have said, we want the solo orderer type. This is for the development, and here's the address, orderersunshine.com, and this is also the name of the service and also the name of then of the Docker container, so that we find this. And here you can see some information. So sometimes the question is, when is a new block generated? And here are the settings for this. So this patch time is 2 seconds. So that means in this case here, every 2 seconds a new block is created from the orderer system. And yeah, maybe that means that every transaction will have its own block because of the 2 seconds limit. But there's also a batch size. So we have here the max message count is 10 transactions, and we have also a maximum number of bytes. And so, but I think that's when the batch time 2 seconds or the patch size is matches first, and then we'll create a new block. So, but I think you can say that every 2 seconds in this scenario, we will have a new block. And that means in reality that in our test scenario, that we will have every transaction in a single block. So maybe you can inspect this when the network is running. So you can look into the blocks, you can fetch a block, and you can look what is into this block. Okay, so these are some information, but also defaults. There's nothing to change from here. So okay, there are also defaults, and the channels are also defaults. So, and the only thing what we have to look now is in this profile section. So this profile section is a part where you can define different profiles, and when you call the Configtx again tool, you can say what do you want from this Configtx YAML file. So, and we can have here different configurations. So we can have here different orderer configurations, and then we can say, okay, Configtx again tool create the Genesis block for this profile as a one orgs orderer Genesis. So that's only a name. You can name it how you like it, but you can have here different orderer Genesis configurations. So, and then you can try what happens when you change this. And the same is for the channel configuration. So we have also one orgs channel profile here, and we have a consortium, and these are the points here. So we define here in the order Genesis with the consortium. This is the Sunshine Consortium, and in this Sunshine Consortium, we will have one organization, and this is the producer organization. So this is the value which we have created here on top on this file. So this is the producer. So this is our organization. These four elements belongs together. So. And when we have a second organization, and then we will have here another line, the third line, and so on. So, and yeah, and for the channel configuration, it belongs to this consortium. So the channel belongs to the consortium Sunshine, and these are the defaults which we have seen in this file a little bit earlier. And here we also define we have to set which organizations belong to this channel. So, but you can say in Fabric, okay, we have a channel, yeah, we have different organizations, but not all organizations belongs to all channels. So we can have we can have 3 organizations, and one channel belongs to organization 1 and organization 2, and we can have another channel which belongs to organization 1 and 3, and so on. So, and that's the reason I think why we can here say, okay, this channel belongs to producer or seller or accounting or marketing or whatever. So, and I think that's it for this now. So, and with these settings, you have a customized channel configuration, and but with default settings from the solo orderer, but also with default settings if you use Raft or Kafka. But I have deleted these profiles here. When you look in the original file, Configtx YAML file, you will have here more profiles and examples how you configure this in the Kafka case or in the Raft case. And for now, we have only these 3 ordering systems: Solo, Kafka, and Zookeeper, and Raft. And as I have mentioned in the 2.2 version, I read in the documentation that Solo and Kafka is deprecated. So, and that means to me that in the future, in the near future, I think only Raft will be the winner in this race. But I don't know. Okay, so this is this file, and this is this file. So, and these are the 2 files we have to look in. And then the last file is the Docker Compose file. And so, and the Docker Compose file controls the network services for us. And one thing to know here is that here I have set volumes, and with these volumes I have persistent data. When you don't do this, you will have not persistent data, and that means that when your network is stopped, then you will lose your blockchain and all other informations. So that's maybe a part to know. So if you want persistent data in your test scenario or not. So that's the reason why here are the volumes. And that's also some problems when you have errors or when you have problems with your configuration, then sometimes the volumes are still there. And then you have to delete these volumes. And that's a good part. I have here in the last section here that's the command, delete all persistent volumes with Docker volume prune. So, and with this step, you can be sure that all incorrect volumes and so on are deleted from your system, that you can make a clean start again. So that's also an important part to know, that when you work with volumes, with Docker volumes, then especially in the development case, then you can have corrupt volumes or corrupt situations, and then you have to clean it up. And of course, you can make a Docker system prune, but that will reset your whole Docker system. But in most cases, it's enough to clear the network file and the volume file here, and of course the excited containers or the chain code containers. So, but to this we will come later. So that's then I will show you how this works. But that's important to know. So in my work, I have often the problem that something not is working because of old volumes, and that's the reason why I've mentioned this here. So, and then we have here our network configuration, and we need to set a network name. So we call this network Sunshine, and we have services. And for this, we need 4 services. We need the orderer service, and we need the service for BS0 and BS1, and a CLI container. With the CLI container, we can interact with the Fabric network from the command line. So we don't need Node.js SDK or Golang SDK to interact with this network. So as a system administrator or as a Fabric administrator, from the point of view of the administrator, you can use the CLI container to interact with this system, with your system. So that's the reason why the CLI container is important. And it's also a specific container. So it's called Fabric Tools for this. And this Fabric Tools container have everything installed which you will need to interact with the containers. So, and that's a service which we need here. So, okay. And so this is also in one file, but we have another file here, the spear base YAML file. So when we look here into the first service, so this is simply a YAML file, and the YAML file is, you see this is so, I don't know, is structured in this way that you can have here 2 spaces or 1 tab to structure this file. And here you have the service name, and this is the service name, and this is the container name. So when we when the system is running, then we have to know which is the container, which is the container, the orderer container, and we here can look at these names here. And when we have some information which we need in different services, Docker gives us the possibility to extend this, and we can include this from another file, and this is done with this extend command, and then you have to specify a path to another YAML file. So, and this is the beer base YAML file, and in this beer base YAML file we have 2 services. So we have 1 base configuration for the beers, so, and 1 for the orderer. So in our case, for the orderer, this is not necessary because we have only 1 orderer. But when you have when you use Raft, for example, then you have at least 3 or more orderer container, and then you need all the same configurations maybe. Then you can have here the orderer base configuration, and this is included in the Docker Compose file here. So that's the reason why this is split so now. And in our case now, it's not so much information here, but when we next time when we enable TLS, for example, then we will have more environment variables which we can define here, and then it makes sense to do it in such a base file, and we don't have to copy and paste all the information into the Docker Compose file. So it's large enough, these files are large enough, and so it's a good way to keep it small. Okay, so, and that's why here that we extend here, but that's not needed, so that's only, it's a little bit easier to, well, it's better to handle. And then we have here volumes, and with this volume we can import something into the container. And what the orderer need is the channel config, the Genesis block from the channel artifact folder, which is generated to the from the generate process. We will see a little bit later. And here, these are the paths. These paths, this is the path where the orderer, the Genesis block from the orderer should be. So I think this path is fixed. I think so. That's maybe in the core file. Maybe you can change this, but I don't know. So, but I think this the right side from the volumes definition. So these are default paths, and on the left side we can make our adjustments where our Genesis block is stored. So, and in my case, I have called this channel artifact. So this is a method which is very common in the examples. You find this on different places. And here, the Genesis block. Of course, this is the orderer. The orderer needs access to the Genesis block. They have to know where's the Genesis block. And the second thing what we need here is the membership service provider. So the membership service provider is one of the important parts from Fabric. This is the part where we can where we will have all crypto materials for this particular member of a network. And the orderer is a member of the network, like a user, like an admin, like a peer, and so on. So every member of the network needs a membership service provider. And the information from the membership service provider comes, in our case, from the CryptoGen tool or from the Fabric.ca container or from the Fabric.ca service. And the right part is also the default, I think the default path configuration for this orderer membership service provider. So in this way, you map the local host, so a file from the local host in the container. And in this last point here, this var Hyperledger production orderer folder, as the name mentioned here, this is production. So then you have here a volume, and in this here lives the blockchain. The blockchain data lives in this folder, and since we have a volume here, that leads us to have persistent data. So when we comment this out, I think then the system will also work, but we don't have the data anymore when we restart the network. And that's the port definition. So this is the default port for the orderer. And for the peers, I think it's basically the same structure we have seen here. We have a service, yeah, and we have the container name. So over the service name, we can interact with this, and the container name is the name of the container. And also the peer base YAML file, which we see here is it. And here we see a little bit more, this important part, environment variables. So when we look here, we compare this both. So these are some important information. So with this environment variables, we can define the peer ID, the peer address, the peer listen address, so the chain code address and chain code listen address, and here also these bootstrap gossip variables, both of them. And very important here, the last one, the core peer local MSP variable. This is the part where the system, the CLE container, for example, will know which organization is used, and then which crypto material is used to interact. So, and with this environment variables, we can change the configuration. But in the case of the peer, it's not important to change this here. So this is the configuration for this. And for the peer one as well. And when you compare this with the CLI container, we have here this one, these 3 lines here. And you see, when you start the CLI container, the CLI container has to know, okay, I will connect to a peer, but to which peer? And in which name I will work now, you can say. And this is done with these 3 environment variables. And when we are into the CLI container and we would like to change to another peer or to another organization, then we have to change this three environment variables to the another peer or to another organization or to another user here. So, and when you have, for some tasks, you need an admin user. So only admin user can invoke and install a chain code. But a normal user, a client user, can invoke and query a chain code when the chain code doesn't have any restrictions to this particular user or to this to the role of the user or something like this. So, and these are important things here to know, that when we're inside the CLI container, then we have direct access to a peer. And when we want to switch to another peer, we have to change this environment variables. So, and that's the CLI container for. And as you can see here, for the CLI container, we need also some mount points, some mapping to the local host. And yeah, you can see, okay, of course we need the chain code. So when we install chain code, we do this with the CLI container. So we need access to the CLI container. We can copy with Docker the chain code into the CLI container. You can do this, but it's, I think, more efficient when you map this here. And also, you need the path to the crypto config folder and to the channel artifacts folder here. And as you can see here, Docker has some, you can control the boot process, the starting process from the Docker system. And you can see here, this CLI container will be ready when the orderer, the peer 1, the peer 2, the peer 1, peer 0 and peer 1 is ready to work. So, and this, I think, is what you have to adjust when you try to build a network like we have it in the big picture. And one thing here in the base is only that we have here, that's so Docker core host config. So this is something I have mentioned in the developer course several times. So don't store usernames, passwords, and so on in the Docker Compose file. So you can use the environment variables from the .env file. So when you have a .env file, Docker Compose will look for this file and use these variables in the Docker Compose file. And then you can check in a Git repository all your configuration files, but you don't have to check in the .env file. Yeah, dot is in the Linux way a hidden file, so you don't have to do this in the Git repo, and you can copy this later in this folder. So, and with this you can hide a little bit your username, so credentials, and also this stuff. Okay, so I think that's the structure which we have seen. And when we look into the when we compare this with this, and you can see here, we will have an orderer service, something like this. And then we will have the producer, sunshine.com. This is our organization here. And then we have these three services here, the peer 0, the peer 1, and the CLI container. And that's this here one. And then we will have here, yeah, and that's the part which we have to do now. So that's all for the configuration. So, and when you can when you try to extend the network on another peer or another host, then or other configuration, so maybe you will start the Fabric CI to a later time, then you can have also a second Docker Compose file, but with a different name, of course, and you can start the second Docker Compose file to a later time. So that will work. But the only thing you have to look is that you be in the same network. So when you start Docker Compose file 1 in the Sunshine network, and you will start Docker Compose file _1 YAML to a later time, then it will the services will be accessible in the same network when you will have here the same network name. And that's the interesting part when it comes to multi-host configurations. Then you can use the functionality from the Docker overlay network. So that comes from Docker Swarm, but you don't have to use Docker Swarm or Docker Swarm services. You can only use Docker Swarm overlay network. And then with the same network, with the same Swarm network name, both hosts could connect together, and then you will have two Docker Compose files and two different hosts with different public IP addresses. And through the Docker Swarm environment, you will have an overlay network, and these both Docker Compose files work in the same network. And that's a really cool thing. Yeah, and that's the part here. That's the reason why the network is important for this. Okay, so I think these are all to the configuration, and then we have to the first step is I have here a list, and this is also in the repo, in the GitHub repo, all the single steps here. So please try it at home and try to create this network. And the first step, what we are going to do now, so I will do this a little bit larger. So, and yeah, so we can use as a terminal multiplexer for this. And so we need two terminals for this example. So, and then this example, this is the project folder, which is also in the GitHub repo. And the GitHub repo has everything involved, but not the crypto artifacts folder and not the crypto config folder, because this is generated to the init script here. And the first step is that we have to create the crypto material. And this is done here in different steps. So, but the steps are really simple. So we have seen this in the presentation. So we have an export variable for channel name, and important, we have to set a system channel name. So that's maybe an important part that we have to know, that when we create here the channel artifact, the Genesis block, we have to set the system channel name. So, but we need here, first we need some environment variables. So the path to the config directory, so has to be set, and here the channel name and the system channel name. So that's for the script. And then here it's a short hash configuration to check if crypto config on channel artifacts is set. And if it's set, so we delete this directory so that we can clear up these two folders. And the first step is, as I've mentioned, the generation of the crypto material. And this is done with the cryptogram generate command. This is here. And yeah, I think that's, we can leave this. And this Configtx gen file, this is the creation of the order Genesis block. And you see here, the Genesis block is stored in the channel artifact. And the next step is to create the channel configuration transaction. So, and you see here the profile names. So that with Configtx scan and the profile option here, we can say, okay, we want the Genesis block for these configurations. So when we change this to another configuration, we can use the same Configtx file, but we have access here to different profile names, and so we can test different configurations. And the same here for the create the channel config transaction part. And yeah, it's basically the same. So, but here you have the channel name. So of course we have to say which channel we are going to create. And we need also a file where this channel configuration is stored. So, and this is also channel underscore and then the channel name, but the name is, yeah, depends on you. And here also the anchor beer transaction, it's in the same way. And here, then this first step is done, and then we can have here tree command. Tree is very useful to list the folder and the file structure recursive. So then you can look where you can control very easily what is in your file structure. So, and now when we do this, so we have to look at the time, and you see, okay, no error. And you see here my first command. So I have looked into the crypto config file, and you see here in this structure, we have order organizations and we have the sunshine.com order organization. And then we have a peer. Under the peer organizations, we will have one peer organization. So that's the output from this command here. And then in the channel artifacts, we have the Genesis block here, and we have the channel configuration, and here is the anchor beer update configuration. So also all three files are here. So, and that's the first step. So now we have everything generated. So we can look in this, but we have to look a little bit deeper in this file. So with the tree, you see this is this crypto config is split into two main parts: the order organizations and the beer organization. And the order organization, you see. So with the L parameter, yeah. And you see here this organization structure. So you can see here information for the certified authority. You see here the membership service provider folder with the artificial materials. You see this orderers, TLS, and users, and so on. So, and the same you can see here in the peer organization too. So, and when we look into this, more important, this is the producer MSP. So, and you see here from the organization. So when we look to the peer, we have to look in the peers. Then we have here two peers, and then we have peer 0 MSP. And then we will have here the membership service provider informations from this peer. And you see here, crypto again creates you all the crypto material for different scenarios. So we will have here TLS certificates, but we don't need TLS for the moment. We have here signer certificate. You have the private key from this. You have also the certificate authority certificate, but we don't have any Fabric CA at the moment. But when we create a Docker container with certificate authority, then we can use these folder information to keep this running. And this is also an important part, config YAML here, but that's also a part for the later because we are running out of time a little bit. So config YAML is really important when it comes to extend the network or use other more users and so on. So and that's an initial part from the membership service provider folder here. Okay, so that's now you will have this, and then we are ready with this, and then we can start the network here, and we can do this with the command docker compose and docker compose up. So when we do this in this way, so it's the docker compose file starts not in a detached modus. So when we stop this, our network is finished, is stopped for the moment. And but we have the second terminal, so it doesn't matter for now. And now the network is running. We can check this with docker compose ps. So, and you see all your containers are up and running. The CLI container, the orderer, and peer 0 and peer 1. So, and you see here these commands. And from now on, we can, the next step is we have to use the CLI container. And we have, and in the CLI container, we have to create a channel. We have to join the channel. And then we have to do this for both peers, peer 0 and peer 1. And then we can install and instantiate some chain code, and then we can query the chain code. And this is done in I think we can do this now. So jump into this container, docker exec. So you can go into a container with the command docker exec, and this IT here, it means interactive. So you are in this container, in the container CLI, and the last param here, bash, is the command which you are going to use in the container. And when you look here, these are the folders you have mapped from the host to the container in the docker compose file we have seen before. Okay, so we need the channel name. So I have stored this in an environment variable, so I can reduce a little bit the amount of lines here. So the first thing is we can create the channel. So, and this is done with the peer channel create command. So, and when in this example, we don't use TLS. So the only thing what we have to say is, okay, which orderer? This is the orderer service and the port, and the channel name, and where we can find the channel configuration. And this we have seen in channel artifacts folder. This is our channel configuration. And then we do this, copy this in, and we see we have created the channel. And the next step is we have to join this channel. This is done with the peer channel join command and the channel block. So, but we have, yeah, okay. And then you will have this message, successfully submitted proposal to join channel. And you control this with peer channel list. So, and you see, okay, my channels peers has joined. This is this peer, this particular peer has joined this channel called my channel. And we should look fast in the print environment. And we can grab the core variables. And here we have these three environment variables, which the CLI container uses to connect to a particular peer. So the CLI container knows now that we have in the producer organization. And we need this MSP config path, and this is the config path to the admin MSP. So because the admin is allowed to create a channel, create and install chain code and so on. So, and okay, we can do this also for the anchor peer. Also done, and then we have to switch to the peer 1, and we can do this in a way that we only change the environment variable. So with the export command, we set a new environment. We write this variable new, and then you can see here, okay, that's peer 1, yeah, and there's a different port. So this will peer 0 on another port, and this peer 1 is also on another port. And you look here. Okay. You have here the same channel block, yeah, because through the creation process we have received this my channel.block, and we can use this to join also peer 1 to this channel, and with peer channel list you can see, okay, has also joined to this. Then we switch back to peer 0, and then now we are ready to install the chain code. So install the chain code is simple. So we can use the peer chain code install command. That's the process for Fabric 1.4. In the 2.2 versions, there are another commands. There's another life cycle for the chain code installation. But in 1.4, we can do this in this way, and we have to set a name for the chain code, a version from the chain code, and where the chain code lives. And by default, Go is used, so we don't have to say that's a Node.js or a Java chain code. So when we don't have a parameter for the language of the chain code, then Go is used. So, and we have also in the CLI container on this path, you can see here GitHub. So that's a little bit deeper. So and you see here the chain code, and you see here the suck chain code. So, and it's also mounted from the host. And then we can install this. So, and you see, okay, installed remotely, process, payload, okay, everything looks good. So, and when you install a chain code, the chain code is that what we want. So we need we have a running Fabric network, and we have a ledger, we have a Genesis block. So, and now we have also a channel, and on this channel we can have different chain codes. And this chain code, and when you install a chain code, you have to install it. And then, but when you want to use it, you have to instantiate it. And that's the second command which we need. So on peer 0, on the first peer, we have to instantiate the chain code. And that depends on the chain code. So what is the initial command for the chain code? In the standard chain code, it's also it's single method, a key, and the value. And I said this is message 1 is the key, and hello is the value. And with this parameter p, we can set that's called the endorsement policy. That's another interesting topic. But for our scenario, we have only the producer organization, and we have only to say, okay, one. But this means only when the producer MSP, the producer organization, said this transaction is valid, then this transaction is also valid. But when you have two organizations, then you can say, okay, producer organization 1 and organization producer must have the same state of ledger and must say, okay, this organization is valid, and then the transaction is finally valid again. So this also one. So, and now we have the chain code installed, and we have an instantiator. Then we can switch back to the peer 1, and we have to install, and that's an important part for your understanding. So in Fabric, there are several terms for peer. We have learned the anchor peer, that's between the communication between organizations is responsible. Then we have an endorsement peer, and then we have committing peers. And committing peers and endorsement peers are the same, but the difference is when you install chain code on a peer, then it comes to the endorsement peer. And that means that only peers with only endorsement peers can invoke chain code and query chain code. And when you don't, when you use the peer, then it's only a committing peer. So that means that this peer holds only the data, but you cannot invoke and you cannot query this peer. So and when you want an endorsement peer, you have to install the chain code. So when we do this, so you can see peer chain code. Installed, and with the command peer chain code list installed, you can see on the peer which chain codes are installed here. So this command is not in the list, but you can find it very easily. So and now we are ready. So and then we can query. So now we have an initial value from the message one, and when we do this, and you see the value hello. Do we exit here and then we know Docker PS and then have a look on this. So, oops. So, and you can see here all the chain code, all the Docker container are running, and you see here this both dev peer 1 and dev peer 0 container, and these are the chain code containers. So every chain code runs in a controlled environment and in a single container, and every peer has its own chain code container, and these chain code containers are started automatically when you install and instantiate a chain code. So, but you don't see this chain code container when you say Docker PS, and you see only so. The reason for that is that Docker Compose looks onto the services on the Docker Compose YAML file, and we don't have a setup for these both chain code containers, and that's the reason why you have to look with Docker Compose. And also Docker Network LS is a good thing. So, and you say here, here is our Sunshine network. This is the net sun. This is our network. Docker Net Sun, Docker Net Sunshine, and you can also say Docker Network inspect Net Sunshine. So, and then you see here in this. So that's a little bit. Control P. Okay. So the scrolling with the terminal multiplexer is a little bit different. So, and you see here, when you say, this is our network, the network was called Sunshine, and then the environment variable here, in this one, we have set the net prefix here, and this is our network. And what you can see here, also for troubleshooting, is are all your containers inside of the network? And with this command, you can control this. And you see here the containers. That's a JSON file, and you see here, okay, this is peer 1, this is peer 2, and you see here the IP addresses for here for this. This is the CLI container. And also both chain code containers are in this network. So, and also the orderer is here in this network. And with this command, you can, that's good for troubleshooting. So when your orderer is not in this network, then you cannot connect to the orderer. Or IP is not in a network, you cannot connect to the orderer. So that's a good point to see when something not is working, then you can look, are all containers in the same network? And that's, I think, a common mistake which can happen. Okay, so this was this. So, and then, yeah, so, but we can, that's what I would like to show. The last thing, so you can also invoke this, so we have to, so one method to interact with the as an admin with the network is inside the CLI container. So and then we can look. So this is the message 1. So, and message 2 is sunshine.com. And this is one method to query, to check if the network is ready. So from the administrator perspective. So, but you don't have to go inside this container. You can do it also from outside. So the only thing you can, for this, you can use the docker exec command. And it's pretty much the same. So you can say docker exec CLI and then your command. This command is the same as you have to set inside the container. And when you have this as a prefix, so you can, this is the query. So you can query the container, the blockchain are also from outside when we use the docker exec command with the same arguments. And more important is when you want, as we have seen, the default configuration is for the peer 0. So, but when we want to query the peer 1 from outside, then we have to change the environment variables, and we can do this with the E option here. So when we have, and you have to set for every variable, you have to set another E option, and in this way you can change the environment variables for this particular command. And then we say we want to check if this information is also stored in peer 1, and you see it works. And you can do it also. You see here we have a different peer number, different port, and here as well. Check sunshine.com. Okay, so and now you have a running system with installed chain code in this configuration. And you can find this example here on this GitHub repo. You have all the steps here. And please try this example and try it out and play with that. And then next session, we are going to use this sample again. And then we will extend this example with TLS, with another peer. And we will add Fabric CA that we will see how we can create new users. So, and that's a really good scenario for prototyping. So last week, people asked me to create a prototype, and then the question was how we can do this. So, and then I said, okay, we can do this in a way that we have CryptoGen as a tool. So we have the crypto material ready for the network, for a single organization, for order system, for TLS, for example. But we need, for this example, different users, and the chain code should have should control different roles, so that we know that when the chain code is called from user from identity A, that this is identity A, and or when the chain code is called from another position, then it's identity B, and so on. So, but for this we need specific users, and we don't want to have user 1, 2, 3, 4, and so on. And for this, we can create a Fabric container, include this in the Docker Compose file, and then we can create this specific users for this chain code. And how you can do this, this will be maybe part for the next session. And yeah. So I think that's from my side. So the last thing, okay, Docker logs, you can see this here. So to try this, you have to start the network in a detached mode. And to start the network in a detached mode, that means in the background. So then you have to here put the parameter D, yeah, -D, and then the Docker Compose network runs in the background, and then you can call the logs command, Docker logs command here, but we can do it here in the terminal. So, and you see here, this is the Docker logs command. So important is the F parameter here. So that means that the log is continually when you don't use the F parameter, then you have a log until now. So it's finished. So that's the last log entry. So, and when you use this F parameter, you can monitor the blockchain, the peer, in this case, the peer 0. So, and that's also useful for troubleshooting. So when you have problems to connect to this peer, or when you want to see what happens exactly on this peer, and then you can have here this, you can log this only on this peer. So that's also helpful for the chain code containers when you debug the chain code, some chain code values from your chain code. And this we have seen, network inspect. So that's also important to know, are all my containers in the same network? And then here the cleanup process, Docker Compose stop. I think that's clear. In this case, we have to say Control X. And Docker volume prune. So we, when we say stop, Docker Compose stop, then the network is stopped. And then when we say Docker Compose up, then we can continue the network and the data is not lost. And yeah, but we can clear it all. And here some typical commands for the remove Docker RM. Remove Docker RM means that you clear only containers, but RMI will clear the images. So be careful with this command. So RM clears only containers and not images, and RMI clears images. And you can also use some specific commands here. So if you only want to clear the chain code container, then this is a commonly used command to clear only the the chain code containers. So, but this is more for the development. So as an administrator, you should have a working chain code, and you don't have to think so much about chain code configuration. Okay. So I think I have tried to give my best to be under 1 hour, so that we have time a little bit to discuss and have some, and if you have some questions. So, but you see, it takes every time it takes a little bit more. But I think here you have a good starting point to see how you can create a network. And I think it's important to try this and go a little bit away from the example.com. From the build your first network example is a very good example. It's very good for chain code development. So as a chain code developer, you can use this build your first network example, and then you have can test different configurations, CouchDB, FabricCA, different ordering system, and so on. So you have by default 2 organizations, and you can test the endorsement policies and so on. So that's pretty good for the chain code development. But when it comes to the administrator, so you want to say your own name here. You want to say peter.com or companyx.com and not example.com. And when you try this, then you have to have some troubles with the configuration files and the paths, and so. And I think with this you have a really good starting point to do this and try it out, and try it with your own configuration, and let me know next time what you have done, and maybe one of you can show me what he or she has done, and we can see that this makes a good, and you have a good progress for this. Okay, so do you have any questions? So if not, so but take this opportunity. You can ask questions. Don't be shy. Ask something. You can also say when you for the next session when you want a particular thing, and when it is okay for the learning process, we will try to include this in the learning process. But what we don't offer here is that we don't give solutions for business problems or something like this. So this is a learning channel. So we are trying to make these presentations to enable you to build such networks and make your own steps and write your own history in this fantastic world of Fabric. And that's the aim of this channel. And please contribute to this. So, and give us some feedback if this is helpful for you. And you can also contact us in the Slack channel. And in the Slack channel, you can also post some topics you would like to see, you would like to know, and then we can try to integrate this in the presentations and try it in the learner and bring it in a learnable modus that we can focus on this particular item, what you are looking for, but not on some specific business problems. So it must be related to a learning topic, and of course to a learning topic of the Fabric administrator or for the Fabric administrator certification. So because that's the aim of this study circle, that you get help for the certification. But you don't have to do the certification, so that's only for learning. So you can learn as much as you want.
Great job, Ronald. It's really, I think it's helpful for everyone to create their own channel and create their own network. Well done. Great job. Thank you so much.
Okay, then thank you so much also from my side, and have a good weekend, and we will see us next weekend again. Bye bye.
Okay, thank you everyone. I hope to see you next week. And if you have any question, we can. Devender, you want to please share your email so that I can send you the invitation. Okay, I will send it. Okay, thank you everyone. Have a good day.